So my name's Chris Feeney. I'm from UKCEH, and today I'm going to be talking about a paper that was published last year, which essentially is on a framework for assessing soil organic carbon status across Europe. So a little bit of background to this. Certainly at the time of writing anyway, the EU's current approach under its proposed soil monitoring law was to look at soil organic carbon status on the basis of its ratio to clay content. Specifically, if soils happen to have a SOC to clay ratio that was below 1/13, then soils would be considered degraded and in need of some remediation. The rationale behind this is that, as carbon accumulates, particularly in these organic carbon clay complexes, you end up with soils getting sort of improved physical structure, and in turn, greater sort of biophysical functioning. So, pretty important from a wider soil health perspective. In 2017, and later, a few years later, by Prout et al. In 2021 onwards, a series of index classes were established for the SOC to clay ratio, which you could use to sort of set grades of like degraded, moderate, good, or very good, separated by thresholds of 1/13, 1/10, and 1/8, which are plotted on these sort of diagonal lines on both the plots. However, the applicability of this metric European scale is rather challenging to really pull off. One of the main reasons for this is that Europe basically straddles the full theoretical range of clay contents, from virtually zero all the way to close to 100%. You can see how this might be problematic with the top right-hand plot there. So the red dots, these are the sort of coarse textured soils with very little clay. And you can see that the overwhelming majority of them are skewed in the sort of strongly sort of very good category. Contrast that with the purple and orange points, which are the fine and very fine textured soils, and most of them are sort of moderate or degraded. So Poplow and Don a couple of years ago proposed an alternative indicator, which was to essentially establish a linear regression function between carbon and clay contents to predict a sort of so-called expected organic carbon content, and then to basically standardize observed SOC values against that expected value. They did this on a sort of national inventory of German agricultural soils, and they took the full distribution, split it up into quartiles to establish 4 categories like you have for SOC to clay ratio. And they found in their work that this actually much more neatly separated out different grades of soil structure as indicated by porosity than the SOC to clay ratio did. That's great, but there's still challenges to applying that indicator at European scale. So Europe, of course, has quite a diverse range of climates as well as land uses. We don't want to go into a situation where, just by virtue of being a woodland, you automatically assume to have sort of very good soil, or vice versa, cropland, degraded soil. So this is where we sort of stepped in. We took the Poplow and Don framework and expanded it. So we swapped out the linear regression for regression tree modeling to establish a decision tree that would allow users to step through a series of questions where they could consider things like not just their soil texture, but also what climate zone they were in and what land cover class they were in. Next, we followed what Poplow and Don did and essentially, split up each of the reference typical SOC values that we came up with from the decision tree into quartiles and tried to see basically how well they represented different grades of porosity and carbon stock and compared that with the SOC to clay indicator. Lastly, we then looked to independently verify how robust these index grades were using national monitoring data as well as long-term field experiments within Europe as well, just to make sure that it wasn't a simple quirk of the Lucas data that we were building our decision tree from. So the result of the decision tree, we ran regression tree modeling, and we were attracted to it for a number of reasons. It allows you to consider a range of different variables, so both categorical and continuous. It allows you to produce a coherent decision tree that users can easily step through, a series of yes/no type questions. And to try and mitigate against some of the drawbacks with this, where it's sensitive to the data that you're using to build the tree, we took around 5,000 random permutations of training versus testing data sets and selected the most accurate one as our decision tree. To give you a sense of how these pedoclimate zones that we came up with this decision tree are mapped across Europe, we combined soil data map layers from EcoDataCube with Corine land cover and the biogeographical regions map of Europe from the European Environment Agency. So you can see how these 12 are mapped, and the bar charts there are just give you an idea of the proportions within each of the countries. Next, we looked at how the two indicators fared in terms of reflecting differences in porosity and carbon stocks. So the two top plots, these are based on the SOC to clay ratio grades. And you can see with the left-hand side, you don't really get very much separation in terms of porosity with the bottom two or possibly even three index classes. Carbon stocks, it's a similar story, but it's really mainly the sort of two intermediate grades where you don't really get much sort of separation. By contrast, with the observed typical SOC index that we presented, you do get statistically significant differences between all of the pairs of box plot distributions here for both porosity and carbon stocks. So it seems to be performing better in terms of reflecting differences in structure and carbon stocks. Next, we looked at status across Europe. So the left-hand maps are based on the SOC to clay index grades, and the ones on the right are the observed typical SOC grades. So you can see with SOC to clay, there's a clear geographical bias in that soils that are in the south tend to be overwhelmingly degraded. And these are obviously soils that are dominated by the warmer and drier climates, relatively speaking. Contrast that with the very good SOC to clay index classes. They tend to be clustered in the north and in areas that are dominated by, relatively coarse textured soils. It's linked to the sort of late glacial loess deposition. By contrast, the observed typical SOC index, there isn't really any sort of geographical pattern. You do see some odd pockets where, there's relatively high proportions of either low or very high, but there isn't any sort of obvious geographical spread there. Next, we looked at how these would be plotted up if we were using different European data. So we looked at the same German agricultural soils inventory that Popelau and Don used, as well as our own GMAP data set covering habitats across Wales. So the top one is the German soils, the bottom one is the Wales soils. And you can see, again, porosity distributions are neatly separated from one another. And it's quite useful to have these two data sets because, one's sort of dominated by a mix of croplands and livestock pasture, whilst the other is a little bit of livestock pasture with a lot of semi-natural habitats. So we get quite a nice habitat gradient and to some extent texture gradient with this. Lastly, we looked at how this might be used to detect, to basically judge sort of changes from long-term field experiment data. So the Rothamsted Research Archive includes a treasure trove of long-term field experiment data, and we selected two of them here. So the top one is from a site called Broadbork, looking at various different farmyard manure trials, and you can see the time series along the bottom. The grey, orange and dark blue, where there isn't really any farmyard manure applied. The carbon just basically bobs around in the sort of low OT SOC status throughout time. Whereas those that do incorporate farmyard manure, you do actually get to observe some sort of transition over time between different OT SOC grades. We also looked at the Highfield bare fallow site, which is another site in England. And essentially this is a sort of natural grassland system that was ploughed up and left as bare fallow and then maintained as sort of bare soil exposed throughout time. And you can see how your carbon status actually drops over time as you go from a sort of pristine grassland system to a bare exposed soil. And it sort of levels off in the late 90s, early 2000s in the low status, having started all the way from very high. Am I out of time? So I'll just very briefly wrap up and say we published the paper last year. It's in Stockton if you want to read it. And there's also some map data in ESDAC that you can download and explore. And yeah, I'll leave it at that.